Good day, everybody. Welcome back to the chapter circles. Let's move on to the remaining questions from the exercise 10.5. The first question, if diagonals of a cyclic quadrilaterals are diameters of the circle, so we have diameters, which means it passed through the center. The vertices of the quadrilateral prove that it is a rectangle. So we have to prove ABCD is a rectangle. A quadrilateral is a rectangle when all the angles are 90 degree. So we have to prove the angles 90 degree. For that, let us consider the angle BAD. BAD is an angle in the semicircle. So it is 90 degree because we have seen angle in a semicircle as 90 degree. This can also be proved using the theorem. BD is a segment. The angle formed by BD is 180 degree. So the angle formed on the remaining part of the circle will be half of 180. So it will be 90 degree. So we have shown that angle A is 90 degree. Similarly, consider the angle BCD. Angle BCD is also 90 degree, the same reason. Again, when you consider AC as the diameter, angle ADC is 90 degree. Same reason, with AC as the diameter. Also, ABC is 90 degree with AC as diameter. So we got all the four angles are 90 degree. So ABCD is a rectangle. Since all angles equal to 90 degree. Let's see the next question. If the non-parallel sides of a trapezium are equal, parallel sides are PS and QR. Non-parallel sides are equal is a given condition. Prove that it is cyclic. A quadrilateral is cyclic if the opposite angles are supplementary, which means angle P plus angle R is equal to 180 degree. That is what we have to prove. For that, let us take a construction. Draw a perpendicular from P to QR, which meet at T, and a perpendicular from S to QR, which meet at U. So these two are perpendiculars. So let PT perpendicular to QR and SU perpendicular to QR. It's a construction. Now in triangle PTQ and triangle SUR, we have a 90 degree. Angle PTQ is equal to angle SUR. Both of them are perpendiculars by construction. PQ is equal to SR is given to us. And PT is the height between two parallel lines PS and QR. The height will always be the same. So PT is equal to SU because it's the perpendicular distance between two parallel sides, PS parallel to QR. So we have 90 degree, the side opposite to it, hypotenuse. So RHS. So by RHS, PTQ is congruent to SUR. Therefore, by CPCT, we get angle Q is equal to angle R. Therefore, angle Q is equal to angle R, corresponding parts of congruent triangles, Q and R. So these two angles are equal. Now, PS is parallel to QR. So we can see the same side interior angles because the lines are parallel. Angle SPQ plus angle Q is equal to 180 degree because PS is parallel to QR. PS parallel to QR. But we know Q is the same as R. From 1, angle SPQ plus, and let's name this as angle equation 2. From 1 and 2, angle SPQ plus angle Q can be replaced as angle R is equal to 180 degree. The opposite angles are 180 degree. If the opposite angles are 180 degree, then the quadrilateral will be cyclic. Therefore, PQRS is cyclic because opposite angles adds up to 180 degree. That was to be proved. Question 9. Two circles intersect at 2 points B and C. Through B, two line segments ABD and PBQ are drawn to intersect the circles at ADPQ respectively. Prove that ACP is equal to QCD. QCD. This is what we have to prove, not given to prove. Let us take the segment AP. To the segment AP, ACP is an angle on the remaining part of the circle. Also, PBA is the angle on the remaining part of the circle. So if this angle is X, this will also be X. So let us write down angle ACP is equal to angle ABP. Angles in the same segment are equal. So we get these two angles are equal. But angle PBA and DBQ are vertically opposite angles. So this is also X. But angle PBA is equal to angle DBQ. Vertical angles. Again, in the second circle, we can see DQ is the segment. So angle DBQ will be the same as angle DCQ, angles in the same segment. In the second circle, angle DBQ is equal to angle DCQ. Same reason, angles in the same segment are equal. So if this is X, that is also X. So finally, we get these two are equal. So let us name, this is equation 1 and this is equation 2. From 1 and 2, we get angle ACP is equal to, we get ACP is ABP, but we have ABP is DBQ. And finally, we get DBQ is QCD. So angle QCD from what? Equation 1 and 2. That was to be proved. Once again, in the same segment, we have these two angles are equal. So we have both of them are X. Now vertical angles, these two are X. Same segment, these two are X. So we got ACP is equal to QCD. Moving on to question 10. If circles are drawn taking two sides of a triangle as diameters, so we have diameters here. Let us name it A, B, C. So AB is a diameter, BC is also diameter. Now we have to show that the point of intersection of this circle lie on the third side of the triangle. For that, let us consider the common chord there. And we can see that angle ADB is 90 degree because that is an angle in the semicircle. ADB is equal to 90 degree angle in a semicircle. Also, angle BDC is 90 degree. Same reason from the second circle. ADB plus, so we have 90 degree and 90 degree. Therefore, angle ADB plus angle BDC is equal to 180. So it's forming a straight line. Therefore, AC is a line where two circles meet, which is on the third side, which implies it is on the third side of the triangle. Moving on to question 11. ABC and ADC are two right triangles with common hypotenuse AC. So we have an hypotenuse AC and we have two right triangles on either side of this hypotenuse. We have to show that CAD and CBD, so we have to join this. These two angles are equal. This is what we have to prove. Now this is a right triangle. So opposite angles are 180. So this quadrilateral is cyclic. ABCD is cyclic because angle B plus angle D is 180 degree. If the opposite angles adds up to 180, it is cyclic. When we consider the segment CD, we can find two angles in the same segment and they are equal. In the segment formed by the arc CD, angle CBD is equal to angle CAD because they are angles in the same segment. They are equal. This is what we have to prove. Now let's see the last question. Prove that a cyclic parallelogram is a rectangle. So given condition, there are two given conditions, cyclic and parallelogram. Cyclic means opposite angles are 100, forms 180 degree. Cyclic gives angle A plus angle C is equal to 180 degree or angle B plus angle D is 180 degree. Parallelogram will give us the idea that opposite angles are equal. In a parallelogram. So we can replace angle A by angle C. So from equation 1, it gives 2 angle A is equal to 180 degree because angle C is replaced as angle A. Therefore, we get angle A is 90 degree. Also, angle C is 90 degree. So angle A is 90 and angle C is 90. Similarly, we can prove that angle B equal to 90 degree and angle D is equal to 90 degree. Since all angles are 90 degree, therefore ABCD is a rectangle. That's the end of this chapter. Well done. So coming soon with a new chapter. That's all for today. Thanks for watching. Have a wonderful day.